In this video, we are going to discuss the definitions of precision and accuracy. I will show you examples of the difference between precision and accuracy. We'll talk about taking measurements on a ruler and how you must add an estimated digit to the end of every measurement. And then we'll also discuss significant figures, or as I typically call them, sig figs. What exactly are significant figures and how can you calculate the number of sig figs in a measurement? Okay, let's get started. Definition of precision. Precision refers to how close together a series of measurements are to each other. So that means that if you have several measurements and they are all very similar to each other, then that set of measurements is precise. Accuracy refers to how close a measured value is to an accepted value. That means that when the measurement agrees with the correct answer or the accepted value, then that particular measurement is accurate. So here are some examples. If a dartboard represents a target and the bullseye would be an accurate measurement, that dart, as well as these next three, did not hit the bullseye, so these are not accurate, and because they are so spread out, they're not close together, these measurements are not precise. So not accurate and not precise. Now we consider that these darts, while they are not accurate because they're not hitting the bullseye, they are close to each other. These measurements agree with each other. So they are precise because they are close to each other, but again, they are not accurate because they did not hit the bullseye. And finally, in this scenario, the darts are close together and they are on target. They are on the bullseye, so they are both precise and accurate. Well, now that you understand the difference between precision and accuracy, let's see an example with some numbers. A woman gets on the scale and she wants to decide if the scale is an accurate scale. So she decides to weigh herself on different scales and her actual weight is 110 pounds. So on the first scale, as you can see from these four measurements, these numbers are not close together and they are not, except for maybe 107 is sort of close, they are not close to her true weight, which is 110 pounds. So like the first dartboard, these measurements are not precise and they are not accurate. If another scale gives her the following results when she steps on that same scale 4 times, while yes, these numbers are close together, 149 and 150, her true weight is 110. So this particular scale is precise because of the consistent, reproducible results that she's getting, but it's not accurate. This scale is off by 40 pounds, basically. Finally, if this scale gives her consistent readings that are close together, 109, 110, it's both precise and accurate because the numbers are close together and they are correct. Okay, now we're going to talk about measuring objects on a ruler. As you can see, and this is a centimeter ruler. It's not labeled as centimeters, but that's what it is. This pencil is longer than 6 centimeters. So we're not able to say it's 7 centimeters. It's definitely 6 point something. And that's where the estimated digit comes in. So I, for example, might call this 6.1 centimeters. And as you can see, the 1 is the final digit, and that is considered to be the estimated digit. Now suppose that we're measuring an object where it falls on the line. We still are unable to call this 6. We have to say more than that, 6 point something. In this case, because it's exactly on the line, then you would record this as 6.0. And the 0 is at the end of the number, and it is the estimated digit. Because it is on the line, you add a 0 at the end. Here we have a ruler that doesn't seem to have very many lines on it at all. But it illustrates the point that I would like to make about how you add an estimated digit. In this case, to record the length of the pencil based on the lines of the ruler, we know it's going to be somewhere between 0 and 10. And that's all we know. Maybe it's 6 centimeters, maybe it's 7 centimeters. Could we say 6.5 centimeters? And the answer is no. every line on this particular ruler is worth 10 centimeters. So you would estimate to the ones place. You estimate 1 power of 10 smaller than what the lines are worth. So in this case, we could say 6, we could say 7, but that's all we could do. Now suppose we have a ruler in which every line that's printed on the ruler is worth 1 centimeter. We can estimate to the 10th place. So perhaps you might call this 6.7, or perhaps you might call this 6.8. Could we say that this ruler gives us a measurement of 6.75? And again, the answer is no, because every line is worth 1 centimeter, so we can only put the estimated digit 1 power of 10 smaller than what these lines are worth. So 6.7, 6.8, but we could not go out to the 100th place. We just don't have that level of precision with this ruler. And now finally, let's go to an even more precise ruler and measure the same object. So, as you can tell, this ruler has every line is worth 0.1 centimeters. I'm going to give you a close-up of expanding what that looks like. So, we are now at a point where we can measure somewhere between 6.7 and 6.8. So let's say we think it's roughly about halfway between 6.7 and 6.8. You might say that the measurement is 6.75 or perhaps 6.76, but the final digit, whatever that number is the estimated digit. And because every line was worth 0.1 centimeters, the estimated digit was 1 power of 10 smaller than that particular measurement. So we go out to the 100th place. Okay, now let's consider some examples where the length of the object, in some cases, is exactly on the line. Remember, we mentioned that we're going to have to add a 0. If the first measurement is just 6, and we cannot say anything more than that because we are only going to the ones place. But now, with this measurement, we are able to go to the 10th place. And let's take a moment to think about what that means. I'm saying that 6.0 is a more precise measurement than just 6. It's a different ruler, and therefore it does require a different level of precision. So, can you guess from this third ruler, if we're going now out to the 100th place with our final digit, this particular pencil on this ruler would be measured as, hopefully you said, 6.00 centimeters. Okay, so that is the most precise of the three measurements. I'm not changing the value. It's still considered 6 on a calculator, but in a science class, 6.00 is a different number than 6.0 or just 6. And that